Hello, this is Robert Davies with the Utah Climate Center. In this episode of Utah Climate Notes, the evidence for global warming. We're continuing our discussion about Earth's rising temperature. The last time we saw what this warming looked like, both spatially, across the surface of the planet, and in time, over the past century or so. But we haven't yet talked about how one measures this kind of thing. Is it just some set of backyard thermometers all across the planet? What are the lines of evidence telling us the planet is warming? It's a good question. It turns out there are many independent lines of evidence, which we'll put in three categories. The first of these categories is direct measurements, and this indeed does include surface thermometers, but much more. Each of these boxes represents a different set of direct temperature measurements, completely independent from the others. There are land surface and ocean surface measurements based on many thousands of instruments, with reasonable global coverage going back about 130 years or so. In addition, there are weather balloon measurements going back roughly 70 years that measure air temperature profiles as a series of altitudes throughout the lower atmosphere. And there are ocean-based measurements that take water temperature profiles at a series of depths in the oceans. Finally, there are surface temperature measurements acquired remotely from satellites. And though these measurements aren't quite as direct as the other data sets, they are nevertheless another important source, with a global record going back about 35 years. And what we find is a consistent story being told by each of these independent collections of data. The Earth is warming, and it gives scientists confidence in the result, like many independent witnesses to the same event, telling roughly the same story. So, if indeed Earth is warming, we would expect to see the effects of the warming in the Earth system. And in fact, this is the case. And two pieces of the Earth system in particular are sensitive to temperature changes. These are the cryosphere, the collection of all the frozen bits on the planet, and the biosphere, the collection of all the living bits on the planet. The cryosphere comprises the continental ice sheets, such as Greenland and Antarctica, the polar ice cap, which is frozen seawater, mountain glaciers, snowpack, and tundra, permanently frozen soil. And what we're seeing across the cryosphere globally is exactly what one would expect in a globally warming world. Namely, it's melting. So, taken together then, these data sets give scientists additional confidence in what their direct measurements are saying, that Earth is warming. Now, within the biosphere, it's a similar story. And here there are many thousands of data sets building a global picture of significant and accelerating changes consistent with a warming environment. Species are migrating away from the equator and toward the poles and upward in elevation. Life cycles, such as when species migrate, when they bud, when they bloom, when they go dormant, etc., are happening earlier in the spring and later in the autumn. And there is a loss of biodiversity, extinctions, that is rapidly accelerating as many species are not able to adapt to their changing climates. Again, all consistent with a warming world and taken all together on a global scale. Finally, one would like to get a sense if perhaps this is just part of some natural cycle. Perhaps the Earth just does this every now and then. To get a better sense of this question, scientists have looked at so-called proxy measurements to understand what Earth's climate was like in the much more distant past, further back than our direct measurements can take us. There are roughly 24 such proxy techniques, and some of the more commonly known are chemical analyses of ice cores, tree rings, ocean sediments, and coral reefs. And while the details of extracting past temperature information from these proxies are complex, science nevertheless understands how to do it. We have expertise in this. Ice cores can give past climate information dating back nearly 1 million years. Tree rings take us back about 6,000 years. Ocean sediments can go back tens of millions of years, for example, and there are many more. By looking at the results from these different proxies and comparing them, scientists understand that the changes currently underway in our climate system are extremely unusual in the record. In fact, they're unique. When compared to the coming and going of ice ages over the past several million years, for example, we find that the current warming is happening much faster, roughly 20 times faster, than the warming as Earth emerges from an ice age. Finally, it's worth mentioning that each of these categories themselves comprise many data sets. And so, From this overwhelming collection of evidence, many independent lines of evidence consistent with a warming world, no lines inconsistent with that conclusion, the scientific community is able to state with high confidence, Earth is warming. Utah Climate Notes is a collaboration between the Utah Climate Center and Cooperative Extension, making essential climate science real for the people of Utah.